Today we are going to solve equations by simplifying constants before multiplying or dividing. You will find that this process is extremely similar, if not identical, to the process we used for adding and subtracting. We're going to gather our constants, simplify, get them on the same side of the equation, and then solve for our variable. Let's take a look. If we had the example 6m plus 19 minus 4 equals 39, and we need to find out what the value of m is, we're going to go ahead and simplify our constants on the left-hand side of the equation first. Again, you'll find this identical to the process that we did with adding and subtracting. Now, just to get our variable by itself, we're going to have to either multiply or divide in our last step. So we can go ahead and we can combine our constants on the left-hand side. We know what a positive 19 minus 4 is. That's a positive 15. We haven't done anything with 6m, so we're going to go ahead and bring that down. Since this is a positive 15, our operation is going to be addition. We haven't done anything with our 39, so we're going to go ahead and bring that down as well. Now we have a constant on the left-hand side of the equation and the right-hand side of the equation. Let's get those constants together on the right-hand side of the equation. Just like we did with addition and subtraction, we're going to undo the addition of 15 with 6m. We undo that by subtracting 15 on both sides. 6m plus 15 minus 15, well, plus 15 minus 15 cancels out to give us 0, and we're left with just 6m. 39 minus 15 is 24. We're left with the equation 6m equals 24. These are the types of equations that we have been working with this week, and we know how to solve those now. We need to undo the multiplication between 6 and m. To do that, we're going to divide both sides of our equation by 6. 6 divided by 6 is 1, so we get 1m. We know that 1 times m is m. We don't need to write that 1. So our left-hand side of the equation simplifies to be m, and 24 divided by 6 is 4. So we found the solution that m equals 24 to make that statement true. But of course, we have to check and make sure our answer is correct. So let's plug that back into our original equation. 6 times 4 plus 19 minus 4, we want to know if that's going to go ahead and equal 39. 6 times 4 is 24 plus 19 minus 4, and we're still looking to see if that equals 39. 24 plus 19 is 43. And 43 minus 4, well, that's 39. And because 39 equals 39 is a true statement, we know that our answer that m equals 4 is correct. Again, same exact steps that we followed with addition and subtraction. We're just finishing solving our equation with multiplication or division. And again, we can have our constants be split in our equation where we're going to have to rearrange our equation to get our constants together. You'll find that I keep saying that this is the same process as when we added and subtracted, because I don't want you to think that you are learning new steps. You're learning the same steps. You're doing the same steps. You're just finishing solving the equation with multiplication or division. When we did this with addition and subtraction, we rearranged and used the commutative property to get our constants together. We're going to do the same thing. 7g is the only variable term, so we're going to put that in the front. Positive 13 is plus 13 plus 16. Now we have our constants together, and we can see we need to do plus 13 plus 16. Positive 13 plus 16, that's 29. And we have simplified our constants on the left-hand side of the equation. Looking familiar? I sure hope so. And what did we do in our addition and subtraction equations when we got to this step? We need to get our constants from our left-hand side with our constants on the right-hand side. And to do that, we undid the addition of 29 by subtracting 29 on both sides. Keep following that same process. 7g plus 29 minus 29, our 29's cancel out, and we're left with 7g on the left. 71 minus 29 is 42. Our last step is to go ahead and solve the equation with one final step of either multiplication or division. Since there's multiplication between 7 and g, we need to undo that multiplication. We're going to undo it by dividing both sides by 7. 7 divided by 7 is 1. Our 7's cancel out, and we're left with g. 42 divided by 7 is 6. And we end up with the solution that g equals 6. Is that correct? Well, I don't know. Let's see. 13 plus 7 times 6 plus 16 equals 71. We're going to go ahead and plug our solution back into our original equation. 13 plus 7 times 6 is 42 plus 16. Does that equal 71? Let's keep simplifying to find out. 13 plus 42 is 55 plus 16. 55 plus 16 is indeed 71. Since we end up with the true statement that 71 equals 71, we know that g equals 6 is our correct solution. We have our steps to solve equations when we need to simplify our constants before multiplying or dividing. And you'll notice, if you take a look back at your notes, that these are indeed the same steps. We have just changed the words down here at the bottom in our last step to say to solve the equation using multiplication or division. Okay. So we're going to use our commutative property to rearrange our equation so that our constants are together. We don't change what side the constants are on, and if we can simplify on both sides, we're going to do that. We'll complete the operation between the constants, and then we're going to solve the equation using multiplication or division as normal. Let's use these steps to go ahead and line them up with how we solve the equations. Step 1. We're going to use the commutative property to rearrange our equation. We're going to get our constants together. Since b over 3 is the only variable term, we're going to bring that out front. A negative 3 is the same as minus 3. Remember, we're using our signs interchangeably with our operations. We're going to bring down that minus 12 because we haven't done anything to it yet. Same with our 30. So now we have our constants together. We're going to go ahead and complete the operation between the constants. Minus 3 minus 12 becomes minus 15. We're going to go ahead and we're going to get our constants together on one side of the equal sign. We're going to do that by adding 15 to both sides. And once we do that, we get b divided by 3 minus 15 plus 15. Our minus 15 and our plus 15 cancel. And we're left with b over 3, or b divided by 3 on our left. 30 plus 15 is 45. Our last step is to go ahead and solve for b. This time, b is being divided by 3. How do we go ahead and we get b by itself? Well, we're going to multiply both sides by 3. over 1 times 1 over 3, that's 3 over 3, which equals 1. Therefore, when we multiply by 3, we see that the 3's cancel out. And I apologize for running out of room. I'm going to jump over here to continue. So 3 times b over 3 simplifies to be b. 45 times 3, well, let's see, 5 times 3 is 15. Carry the 1, 3 times 4 is 12 plus 1. That's 135. So we solve the equation as normal using our multiplication or division. As always, you should go ahead and you should plug the value that you solved for your variable back into your original equation to check and see if it is correct. For the time purposes of this video, I'm going to go ahead and skip this process. Please make sure that you do that on your own to ensure you have obtained the correct solution. All right, let's take a look at our last example where we have constants that can be simplified on both sides of the equation. And we're going to go ahead and do that. We're going to rearrange our equation so that our constants are together on the left-hand side. We'll simplify those, and then we'll simplify the constants on the right-hand side as well. Let's take a look at what that's going to look like. A divided by 8 is the only variable term, so I'm going to bring that out front. This is a positive 8, so positive translates to plus 8 minus 5. So we have rearranged our equation to make sure that our constants are all together. Now we're going to go ahead and complete the operation between our constants to simplify. We haven't done anything to a over a divided by 8, so we're going to keep that. Plus 8 minus 5 is a positive 3. 24 plus 5 is 29. So we have simplified our constants. Now, we want to get all of our constants together on the same side of the equal sign. We need to undo the addition of 3 from a divided by 8. Remember, we're going to do that through our inverse operation. Since we are adding, we want to subtract 3 on both sides. A divided by 8 plus 3 minus 3, our plus 3 and minus 3 cancel out to leave us with a divided by 8. 29 minus 3 is 26. We now have the equation a divided by 8 equals 26. And this is a one-step equation that we have been working on all week. We now know that we can solve our equation using our normal steps for multiplication and division. Since a is being divided by 8, we undo that by multiplying by 8. Since it's written as a fraction for the division, it appears as a fraction, we're going to write our multiplication as a fraction so we can see how our 8's cancel out. Don't forget that when we do that to the left, we also need to do it on the right. Since our 8's cancel out, we're left with only a on the left-hand side of the equation. And we're going to go ahead and we're going to calculate 26 times 8. 8 times 6 is 48. Carry the 4. 8 times 2 is 16. Plus 4 is 20. A equals 208. Our last step is to go ahead and check that. Again, for time purposes, I'm going to skip that step in this video, but you need to make sure to include it in your process. So as a review, we're using the same steps that we used for addition and subtraction when we simplify constants before multiplying and dividing. Go ahead to your practice and practice these steps on your own.